Lesson 1.5 is right triangle, trig, and indirect angle. So a little review for your right triangle. Remember that it's a triangle that has a right angle in it. We always call C the hypotenuse, which is the side that's directly across from the right angle. And then A or B, it doesn't matter which of the legs is A or B. And then you can use the Pythagorean theorem for right triangles, which says if you have this set up, then side A squared plus side B squared is equal to side C squared. Again, C always has to be the longest side and opposite the hypotenuse. You also have the converse of the Pythagorean theorem that says if it fulfills A squared plus B squared equals C squared, then it must be a right triangle. And if it doesn't, then therefore it can't be a right triangle. So given the Pythagorean theorem and the converse of Pythagorean theorem, determine whether or not a triangle that has sides 6 centimeters, 8 centimeters, and 9 centimeters is a right triangle. So go ahead and pause the video and try that. So remembering that your hypotenuse always has to be the longest side, I made C be 9. So 9 squared is equal to 6 squared plus 8 squared, which means 81 is equal to 36 plus 64, and therefore 81 equals 100, which is not true. So since this is not true by using the converse of Pythagorean theorem, this is not a right triangle. So same thing, Sam's vegetable garden is a triangle. He plans to have it be a right angle. He measures his vegetable garden to be 17 meters, 144 meters, and 145 meters. Show that it is indeed a right angled triangle. Go ahead and pause the video and do that. So again, using the converse of the Pythagorean theorem, C always has to be the longest side. So I said 145 squared is equal to 144 squared plus 17 squared. 145 squared is 21,025. 144 squared is 20,736. And 17 squared is 289. Add these together and you end up with 21,025 on both sides. So yes, by the converse of the Pythagorean theorem, this is in fact a right triangle. Some trigonometric ratios and inverse trig, so this should be review from geometry. So we are talking about right triangle trig, so our SOHCAHTOA. So if you have a right triangle here, this only works for right triangles, and we're talking about this angle down here A, then this side over here would be opposite, this side down here would be adjacent, and this side would be the hypotenuse, like always. So then we have our shortcut, which we call SOHCAHTOA, which says sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And then we also have our inverse trig, so this will give us a ratio. A is an angle. In this class we only deal in degrees, so this is an angle in degrees, and we get out a ratio. Your inverse trig goes the other direction. So if we have that sine of A is equal to some ratio y, then we can find the angle A by finding the sine inverse of this ratio. So we can do inverse trig, so cosine of A is equal to y, then angle A is equal to cosine inverse of y. If tangent A is equal to y, then angle A is equal to tangent inverse of y. So this is how we find an angle if we know the sides. So for this first example, we want to find the size of angle A, so that's this angle down here in triangle ABC, where we know that this angle B is our right angle, and they give us side lengths of 3, 4, and 5. So using your inverse trig, go ahead and pause the video and find the size of angle A. So I set up my trig ratios. It doesn't matter which of the three you use because we know all three sides. So if I use sine, sine is opposite over hypotenuse, so that would be 3 over 5. If I used cosine, cosine is adjacent over hypotenuse, so that would be 4 over 5. And if I use tangent, that's opposite over adjacent, which is 3 over 4. So then whichever one I did, I switched it into inverse form. So I solve for A, so I get A is equal to either sine inverse of 3/5, cosine inverse of 4/5, or tangent inverse of 3/4. And then I just plug this into my calculator. Make sure your calculator is in degree mode so that you end up with a degree angle. That's what we're going to be talking about here. And so once you've done that, you should end up with an angle of 36.9 degrees. This next one, we have this right triangle FGH, and side FH is 14 centimeters, and angle FHG is 52 degrees, and then our right angle is here in G, and we want to find the length of side GH. So go ahead and pause the video and do that. So given the fact that we were given this angle here H, and we want to find this adjacent side, knowing the hypotenuse, adjacent and hypotenuse is cosine. So I set up cosine of my angle 52 degrees is equal to this missing side GH over my hypotenuse of 14. I want to solve for GH, so I multiplied both sides by 14. So side GH is equal to 14 cosine 52 degrees. Plug this in your calculator, you end up with 8.62 centimeters. So whichever side you have or you're looking for, use that trig ratio. Emma is standing in front of a big tree. She measures her distance from the tree as AB is 15 meters. She measures angle A to be 40 degrees. We call that her angle of inclination. Find the length of BC and state what other information Emma needs in order to calculate the height of her tree. So go ahead and pause the video and try this one. So I calculated that we have the adjacent side and we're looking for the opposite side of this angle 40 degrees. So which trig function uses opposite and adjacent? That would be tangent. So I set up my trig ratio as tangent of 40 degrees is equal to opposite, which is BC, over adjacent, which is 15. I need to solve for BC, so I multiplied both sides by 15 and got side BC is equal to 15 tangent 40 degrees, which plugged this in my calculator, ended up being 12.6 meters. So that is only the distance to where they have this point B, so wherever she measured this angle from. If they want to know the entire height of the tree, they would also need to know the distance from B to the ground, or the height of wherever she measured the angle, whether it was her eye height or whatever it was, to the ground, and then add that on, and that would give the entire height of the tree. Lesson 1.6 is angles of elevation and depression. So an angle of elevation is how much you look up from the horizontal in order to see an object. An angle of depression or declination is the angle in which you look down from the horizontal to see something. So if you imagine like this person standing on a cliff, for example, then if they were looking straight forward, the angle of elevation would be how much they have to look up to see this airplane, and their angle of depression or declination would be how much they have to look down from this horizontal in order to see this ship. So in this example, a ramp BC is to be constructed to give wheelchair access to a door of a house that's 1.35 meters off the ground, and safety regulations require that the angle of the ramp to be less than 8 degrees. So we want to draw a diagram, label all the vertices and all the sides, and then find the length of the ramp BC, where angle ABC is 8 degrees, and then find the distance AB given your answer to 1 decimal point. So go ahead and pause the video and try that. So here's my diagram. I labeled this missing angle A because they were using it down here, and then this side AC here is going to be 1.35 meters. That's the door is going to be up here of the house, and then you have angle 8 degrees in here. So then to find the length of BC, this is the hypotenuse of our triangle, and if we're assuming this is 8 degrees, then we have the opposite and we're trying to find hypotenuse. So I use sine. Sine of 8 degrees is equal to 1.35 divided by BC. So BC is equal to 1.35 over sine of 8 degrees, should be BC, and plug that in your calculator and you end up with 9.70 meters. And then part C says find the distance AB given your answer to 1 decimal place. So I'm looking for this side here. There's a few ways you could do it. You have two sides. You could do Pythagorean theorem. You have your hypotenuse now. You could use cosine. I tried to use the one that is not a rounded answer. That's an exact answer. So I chose to do tangent because I have opposite and I'm finding adjacent. So I did the tangent of 8 degrees is equal to 1.35 over AB. So therefore AB would be 1.35 divided by the tangent of 8 degrees, or 9.6 meters. From his studio window at point A, which is 6.50 meters off the ground, Tomczyk views the top and the base of the building opposite him. The angles of elevation and depression to the top and the base of the building are 55 degrees and 18 degrees respectively. Given this information, and assuming again this point B here is going to be a right angle on the building, find the height of the building from his viewing angle, given your answer to 2 decimal places. So I drew my angles in here. I said this would have to be 55 degrees and this would have to be 18 degrees according to the description. I also knew that BD was going to be congruent to AE because this is a horizontal line, so therefore these are going to both be the same distance. So in order to find the distance BC, I need another part of this triangle ABC. So what I decided to do is I decided to use this triangle ABD and find this side here, AB, that I could then use for the triangle ABC. So I know this side BD is 6.50 meters, and I know this angle, so that's opposite, and I'm trying to find adjacent. So I used tangent of 18 degrees with 6.50 opposite over adjacent AB. and I solved for AB and got that to be 20.00494 meters. Now I have a piece of this triangle ABC, so I have adjacent of triangle ABC compared to my 55-degree angle, and I'm trying to find opposite, so again that's tangent. So tangent of 55 degrees is equal to BC plus this 20.00494 that I just found. So therefore side BC is equal to 28.57 and then if I want the entire height of the building, that's BC plus BD. And we know BD is 6.50, and we just found BC. So the whole height of the building is 35.07 meters. The last part of section 1.6 is length of an arc. So if you have a circle and you cut out just a piece of it here, this is called a sector. And then the part that's on the circumference, that's called an arc. So if you want to find the length of this arc, the arc length, then whatever this central angle is, we call this Greek letter theta, and then your radius, then arc length is theta over 360, because you're just taking a part of the whole circle, times your circumference, times 2 pi r. So, or if you simplify it, it would be theta pi r over 180 degrees. So find the length of an arc of a circle with a radius of 2 centimeters and a central angle of 120 degrees. So 120 degrees out of 360, you're just taking a part of the circumference, times the circumference with your radius to be 2, plug all this in your calculator, and you end up with the arc length to be 4.19 centimeters. So this has been a review of right triangle trig and arc length.